Hi everyone. Today we will learn how to start using the Raspberry Pi Pico with a Microsoft Windows machine. This Raspberry Pi Pico is different from other Raspberry Pi models. It is not a single board computer like usual, but a microcontroller instead. There are quite a lot of differences between the Pico and other Raspberry Pi models. The Pico doesn't run Linux like the other Raspberry Pi models, and it also doesn't have a built-in micro SD card slot or networking capabilities out of the box. Besides that, it also has a much lower processor speed and less memory compared to the other Raspberry Pi models. But despite those differences, we are still able to code using the Python programming language by utilizing MicroPython, the implementation of Python-free programming language optimized to run on microcontroller like this. For today's workshop, we will need these components. First, the Raspberry Pi Pico board itself, this one, and then the breadboard, though it is not mandatory actually, but it is very recommended too. And then one piece of LED here, 330 ohm resistor here, micro USB cable, the white one here, and of course computer with Microsoft Windows OS, which is connected to the internet. We will need the internet connection to download the IDE. We will use Thonny IDE here. And then optional USB charger to test whether our Raspberry Pi Pico running correctly without our Microsoft Windows machine. And then we will also need MicroPython, which will be downloaded using Thonny IDE later. Before we continue, we'll take a look closer at Raspberry Pi Pico board. Here we can see the Raspberry Pi pins. There are 40 pins here. The first one is here. This is the 20th. And this one is the 40th pin. If we take a look at pin numbering here, the first pin is the GP0 pin, general purpose IO pin, and then followed by the second, third, fourth, fifth, and so on. We can also see here that all the general purpose pin marked by a green GP0, GP1, GP2, GP3, and so on. We also have 3.3 volts out here from 36th pin, and we also have ground pins. For example, the 3rd pin, 8th pin, 13th pin, and so on. Here in my setup, I also add two jumpers here. The red one connecting the 3.3 volts into this positive line, and connecting ground pin into this negative line. Remember, when we use breadboard, then this horizontal line is connected. Also, this horizontal line connected into the ground pin, and at the center of the breadboard, this line connected vertically. Pico uses micro USB cable. This white cable is connected to my Windows laptop. Also, please take a look here. There's a small button labeled boot cell, which is necessary to program or reprogram the MicroPython inside Raspberry Pi Pico. Now let's start with downloading Thonny IDE. We can download Thonny from thonny.org, and right now the current stable version is 3.3.13, so we will download this one for Windows. I have it already here, the installer. Please also note that right now we have 3 Windows drives, C, D, and E. Before we install Thonny IDE, first power up the Raspberry Pi Pico while holding down the boot cell button, and then while we pressing the boot cell button, connect the micro USB charger here. After we connect micro USB cable from my Windows laptop, we could see there is additional drive here, which is labeled RP2. There is nothing inside, only 2 files, index.html and text document here. We will left it as it is. Now we go back here to our download folder and run the Thonny IDE installer here. I'd like to install it just for me, so I will choose this option. Next, accept, leave it as it is, next, 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 next. See here that even we connect the board into micro USB cable, we didn't see any indication here whether our board is up and running or not. This is normal. Okay, finish. Now run Thonny IDE. I want also to pin this to taskbar. Language, choose your language, and also initial setting. Let's go. This is Thonny IDE at its first start. Then go to Tools, Option, Interpreter, and choose MicroPython for Raspberry Pi Pico. Leave it. Try to detect port automatically and choose this option, Install or Update Firmware. Since we already connected our Pico board into our Microsoft Windows machine, then we could choose this option to install and update MicroPython firmware. Choose Install here. We will start downloading the firmware, MicroPython. Now we'll see this Python shell message, MicroPython version 1.18 on Raspberry Pi Pico. This shell message indicates that our Pico board is ready to use. There's still nothing happens here because we didn't have anything to run inside Raspberry Pi Pico yet, right now. We could see files, and inside Raspberry Pi Pico there is no file at all. We will create our first code utilizing this GP25 pins, which is used by internal LED of Pico. First, we will import pin class from machine module. From machine, import pin. And then we also need to import time module. Then define LED as a LED object connected to GP pins 25. And we will use this as an output pin. Please note that when we state here pin 25, it means we use the GP pin 25 and not the 25th pin over here. So pin 25 here means GP 25 pin used by the internal LED of Raspberry Pi Pico. Then we will create a loop here while true, set LED value to 1, then create a delay, sleep 1 second, then turn off LED again, LED value 0, then sleep again 1 second. Save this code, choose Raspberry Pi Pico. We will name it LED.py, for example. Then run this code. We will see this code running on our Raspberry Pi Pico. It turn on the LED with this code, and then sleep 1 second, and then turn off, and then sleep another 1 second, then going back here. We could change the duration, for example, turn off for 2 seconds and turn on only for half a second, like this. Run again. The result is like this. Okay, this board is running with the power source from our Microsoft Windows laptop. We will try to change the power source. This time we will connect to the USB charger. We will see. This black cable does not connect it to my Windows machine. It connects to smartphone charger. We could see here that our code is not running. Why? To make this code running automatically, we'll need to change a little bit. Connect it again to our Windows machine. This time without pressing boot shell button. Then inside the Thonny IDE, press this restart button. Now we will connect again to our Raspberry Pi Pico, edit this code, and this time rename this, save as, into main.py. This main.py is a special Python code that will be automatically run every time the Pico board power on. So we'll take a look. We'll use this power source, and this main.py code is run automatically. even without connecting to our Microsoft Windows machine. Now we'll take a look at another example. This time we will use an external LED. Connect the board to Windows machine. Then we will use this LED. First, connect this resistor into GP number 15. Here's GP number 15. So we will put it here. Put resistor into the GP 15. Then put the red LED. Positive pin here. And negative pin here. Like that. So the final connection will be like this. Negative pin connected with ground, then positive pin connected to the resistor. Resistors connect to the GP 15. Okay, now we'll take a look back in the code. We'll edit this main.py. Add red LED connected to GP15, and here we'll set the value as the opposite value of the internal LED. Save it and run. We could see now that every time the internal LED turn on, the red LED will turn off, and if internal LED turn off, then the red LED will turn on, based on this code. We'll see even if we disconnect this board from Windows, and it still be able to run the code. Okay, that's it for today. Hope we will meet again next time. Thanks for watching.